It's Don here from the board. Today we're going to be on part 2 of designing and creating the FHANv version 3. Now in part 1 we went through how to use keyboard layout editor to set up and design our desired layout, and then how we went about assigning our rows and columns. So we're just going to do a quick recap on that before we move on to the next part on designing your own PCB. So let's switch over to my desktop, and over here in this window we've got keyboard layout editor showing, and I've logged in of course, and I've actually loaded my setup here for the FHANv3. And as I discussed before, you can have your notes and whatnot on what you've done, what you've changed, what you've played around with, and you can select and highlight multiple keys and then using your arrow keys on your keyboard to move them around until you get your desired layout. Plus, of course, you can add legends and so forth just by going to the Properties tab and putting in the legends in whatever position you like. Now, after we did that though, we had to create some row and column assignments for the purposes of working out our PCB schematic for wiring and connections and so forth. And on the right hand side, as you can see in this picture that we had saved in part 1, we had gone through and added rows in the red and then columns in the blue and put in our dot assignments. Now, remembering that we had some sort of unusual things that have to happen here because we're adding compatibility of 2Us as well, we've done some dotted lines just to remind ourselves that we have to be very careful in this space, because if we don't get it right, the PCB is going to turn out a bit funny, and of course the connectivity and the compatibility will not work. So let's get rid of that window there, and I'm going to move this off the screen so I can actually keep reference on it when I start working on the actual schematic. Now, before we get sort of too much further, I do apologize if there is a bit of noise in the background from the air conditioning, because it's summer in Australia at the moment that I'm working on this right now, and to keep myself and my family cool, I've got it running, and that's just how the way it is. And of course, with a good quality microphone, it's very sensitive and it will pick up a lot of noise. Now, my wife and daughter are actually in the room with me at the moment. I'm on holiday, so I've got the time to do this video. So I do give fair warning that there might be some interference happening in the background, but hopefully we'll be able to just work through it. Now, what I've got now on the screen is Kicad. It's open, and I've already created a new project, which is my FHANv3 project. I'm not going to go through the opening and starting one up, only because it's very simple. You select a folder, you give it a name, you hit save, and it generates these files automatically for you. You will need to have your component libraries and whatnot set up, and you want to have your path set up. Now, I'm not going to go through this because if you follow the guide from Rui Mao, easy to find, and I will have, hopefully, if I remember, links to it as well. You can follow the procedures in that to get your paths and to get your libraries set up. So in this part, we're really going to be focusing on the schematics, and the schematics is identified with the extension SCH, which is this one here. Now, if we double click that, it will open up our schematics editor, which looks like this, and this is your default working page. Up here in preferences, our component libraries are really important, and I've already added my FHANv2 folder into this so that I can actually get my previous component libraries that I had. And you'll see down here below in the search paths, I've actually got a bunch of different folders here where I've got Kicad libraries as well as FHAN2, and in case I have to grab any other ones, the FHAN3 as well, so it will actually search for those. And up here in the component list, you'll see that I've now got a FHANv2 cache directory here, which is going to be really important. So we're just going to hit OK, and that's our generic screen. We're going to start adding components now, and we've got switches, we've got diodes, and we've got a Pro Micro to put into this. One of the suggestions from a couple of different people when I did the interest check was that they actually wanted to have LEDs added. LEDs, light emitting diodes, they're not absolutely necessary for my design and my board. I had a look into it. I asked a couple of people who were more experienced in regards to creating PCBs with LEDs, and it's a bit more complex. There's more things to deal with. There's more traces that you have to worry about. You have to put in transistors and other things as well. And at the end of the day, I made an executive decision for at least this version of the fan pad, because realistically this is only the second one that I've made that I'm going to be making. I'm not going to put in LEDs. Now, if this board comes to full fruition and I do run a buy for it, and it not having LEDs will turn you off from buying it, well, I'm sorry, but I'm not sorry, because that's just the way it is. So enough of that. We'll just keep on going. Now we're going to start adding components. You've got a whole bunch of options on the sides here, and one of these is a place component. So that's it there. But at the same time, you can, I think you can, there's options around. I can't remember what the shortcut key is, but we'll just go with that. And it'll give you an arrow so you can start putting things. I like to work in a position that will give me hopefully enough room so I don't have to drag stuff around too much, but sometimes it doesn't quite work, so that's just you can move stuff around. I don't actually know how to make this page bigger at the moment, so I try to limit myself in how much space I take, just in case I run out of space. So we're just going to click on that, and now it says what kind of components do you want to put on. And you'll see, because I've loaded the library and paths, I've got this FHANv3 cache, which are the components I used from the previous version. And there is key switch, diode, and the Pro Micro. And they're the only three things that I will actually require for this schematic. So of course, we're going to start with our key switches. So we'll just say, yep, there is a key switch. Bam. Done. We've got 7 rows and 7 columns to deal with. And because most of it is actually grid, except for around the arrow keys, we can actually do copy and pastes. So what that means is I'm actually going to do 1 row of components. Oh. And then I can copy and paste it. Now, I'm trying to remember, was there a particular... What have I done? Okay. So there we go. What on earth have I done there? Okay. 4, 5, 6, 7. Now I probably could have actually just copied and pasted that, couldn't I? Alright, so I'm just going to hit escape and get rid of that position, and then we can use the M as a shortcut to move components. So I actually want to zoom in a little bit and try and align them up just to make life a little bit easier, and we'll just line it up to these dots. I do want to have a little bit of space in between them, so how many dots did I do there? 1, 2, 3, 4, 5, 6. So 1, 2, 3, 4, 5, 6. Is that right? I've got 1, 2, 3, 4, 5. So there's 5 in between. 1, 2, 3, 4, 5. Yep. I'm gonna have to move some of these out of the way temporarily. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And that'll be the mailman. 1, 2, 3, 4, 5, 6. And 1, 2, 3, 4, 5, 6. Okay, so there's our base row. Now, what I want to do is I want to add my diodes. So back, of course, to placing component. We're going to head back up to, down, up, around to our diode. There's our diode. Now, I want to rotate that, so you can use the context menu, and we're going to rotate it counterclockwise. So our diode faces down there. And I'm just going to position that so it's going to be what do we say? 1, 2, 3, 4, 5, 6, just to make it a little bit easier. Now I think I should be able to copy component. There we go. C. So hey, let's go C and place. Press C on that again. Place. Press C. Place. Press C. Place. Oh, I've got to click to place, don't I? I'm not very good at making these tutorials because this is only, I think, the second time I've been doing this on video, but that's just how it goes. Alright, so that is our very, very basic structure that we're going to use. And over here on the green line, this wire is essentially the connectivity between components. So we're going to click to connect one part of the switch to the diode. Now, of course, the purpose of the diodes is to prevent the electrical signal going back the other way so that the microcontroller can recognize which row and column it comes from. And what I'm going to do is I'm going to run a wire across that entire row. And you'll notice that when I do these joins, I'm not running it right across as one line. The reason is because if you run across one line and you don't get these circular dots, you might miss the fact that they actually have a connection there. The circular dots, at least on a Y junction, is always good to have to ensure that you get that connectivity that you want. Now I'm just going to drag this back over so we can see what's happening here. So this key should be F1, F2, F3, F4, F5, F6, and this last one is our first customizable on column 6. Okay, now at this point in time, a magic copy and paste would work really well, but I'm just going to save that schematic in case it goes horribly wrong, and I'm going to go drag. All of this is here. I'm going to hit copy and check it out. Now I do have a copy. Ooh, I'm trying to zoom in and out, and I'm just going to line that up. So, oh no, that moved it. Okay, let's go back, undo. So there we go, it's highlighted. Right click, copy block. Okay, so I can't use a shortcut for that, but that's okay. And how many big dots do I want to do? It's okay, I can move all of this later anyway if I need to, but I do want to have a bit of clarity between the rows. There we go. And I'm going to drag all of that and I want to move it so that I'm going to be on another row. Okay, so now we've got 2 rows. I can highlight all of this again. I'm going to copy the block. Check it out. I've now got, now this is 1 dot, 2 dot, 3 dot, 4 dot, 5 dot. So 1, 2, 3, 4, 5 dot. Now I've got 4 rows, and of course it means I still need another 3 rows, so I'm just going to copy the last 3 rows, copy that block, and here we go. So need to zoom in a little bit. There's 1 dot, 2 dot, 3 dot, 4 dot, 5 dot. There we go. Now you can see that I've probably done my spacing a little bit funny because well, I'm running off the bottom of the actual page now, so I may have to shrink some of these dotages. I'm going to just move all of that up. There we go. And then let's, yes dear, Daddy's still here. There we go. So we've got 1 row of space. Hopefully we'll be able to get that to fit in. There we go. If you don't have a child, at the age of around just before 2, they can get very talkative. That, of course, is just my own casual observation of having one of these creatures. And of course, I'm going to shift this sideways just to try and reduce any of that happening over here. Okay, so there we go. That is the full grid of a 7 by 7. So these two rows are the F key rows plus the 2 down the back here, and then we've got some blanks, then the numpad, numlock slash star minus, and insert home page up, delete end page down. Of course, our numpad block over here plus our not quite finished yet compatibility aspect here, but there will be some work that needs to be done over here. And then we've got some arrow keys. But you'll notice that for these arrow keys though, we do actually have some extras, because this is going to be left, down, right, and up. And then we've actually got some extra switches here. So this is when we go in, and I'm going to be deleting out that component. Let's delete that component. We can delete that wire. Let's delete that component. Just hit delete, and get rid of that junction. Get rid of that junction. So that should be a much better representation. Ugh. I still have to get used to using the scroll wheel for zoom in and zoom out. Now you'll notice all of these, by the way, have question marks against them. And at some point in time, I will actually go back through and I will just number them sequentially, because that will help you later on when you're trying to do mapping as well as visualization. And it also can be on the silk screen for your keyboard on the PCB, sorry. And that way, if someone is trying to diagnostically figure out something, it can be handy, because then they can look at the actual reference. Now, before I go and add the extra switches, let me think about this. All right, we should do the compatibility thing first, I believe. So let me see if I can carefully zoom in to where I need to go. And the areas that we're going to be looking at is the fact that down here, these two is actually the same for the enter switch. So the enter switch. The way that it was told to me on how you build a compatibility is that you're going to have another switch hooked up to a particular row or column that will run off the same position, but it's just physically placed somewhere else. Okay, so if this was a 2U key, if this was a single 2U key between these two key switches here, it would run off one of these rows and columns regardless, because it was a single switch. It's just physically placed elsewhere. When we turn this into the 2 switch situation, one of these will be in the middle of the 1U position, the other one will be in the middle of the 1U situation. So we need a physical extra map for it to be in the middle of a 2U position, but it would still be linked to just one switch. When it comes to programming, if you don't use that second switch, you just simply don't assign anything to it. So what we're going to do, because of how we had originally mapped this over here, you'll see the row 5 is where we're actually mapping the middle of that 2U, as well as the fact that there's going to be that same row 5 is in that 1U position. So this is going to be our row 5 1U switch, and then we're going to add another row 5 2U position switch, if that makes sense. So here I'm going to copy, I don't know what I just did there with the picture, but click on it here, I'm going to copy that, and all I need to do is that, because that will be the same position on the matrix for the row 5, but it will just simply be in a different physical position. And similarly, that is the bottom of row 4 for the plus, that's the top of row 4 for the plus, and what we'll do is we'll copy that switch and we'll put that there as well. Now, we need to just make sure that we have the junction. There we go. For the other key though, we now have to think about it as a column. So here is left, down, right, and then this is our 0 insert key as a 2U or a 1U left position, and this is the 2U right position, and then this is the delete key. Okay, now this is when, if we label these actual labels, it would help us understand what's going on, but I'm going to not label this for the moment. So I need to have another switch which is actually going to build off this matrix, because as we see in this picture here, column 3 is going to be the left U and the 2U positional switch. Okay, so we're still going to be in that same position for the row, because the row doesn't change in this circumstance, but it means it needs to be connected into the same column. Now we haven't connected the columns yet, but I will do that in a moment, because I wanted to get the switches in first before I connected the columns. So if I go over to here and I copy that, this is going to be the same key switch in the same matrix, but just in a different physical position. And this switch here is the one that you're not going to program if you're using the 2U in that space. And of course, I'm going to complete that with a junction. Rightio, so that's done. Now we can start connecting our columns. So we're going to go from 1 to 1, 1 to 1, and we're going to keep doing this. Now if you press shift, it allows you to scroll up and down. And then I'm going to come over to the end here, because I need to be able to put my column assignments to it in a moment. So now there might be a faster way to do this, but I'm old school slow, so just have to bear with me here with my poor mouse skills. And you finish that row there. Connected that to that, from there to there, from there to there, from there to there. And then when we get to this double, because they're the same switch, it doesn't matter. We're going to be still connecting them to the same column. And that should work, because if this switch is not in use, it doesn't matter. There'll never be a signal that goes across it. And this switch will be the one that's in use in a different physical position, because they come from that same column and row response that the microcontroller is looking for. Wow, that zoom. Got caught by that zoom. Okay, so we've got 3 more rows to fill in. There might be like a way to copy and paste these wire connections, but I haven't really played around with the wiring terribly much to know. And I didn't really want to try doing that right now. Yeah, I probably could have, tried it beforehand before starting the video, but I didn't really think about it, so you'll just have to bear with me. But this will give you an idea also when you're starting out, that the more helpful hints and tips that you can pick up from watching other people's mistakes like my own, the better, because it will make your own journey into creating PCBs a lot smoother. And finally, the last row. Oh, sorry, last column. So this is the first of our doubles. And we can just end that one there. Okay. Now we have finished the basic matrix. If I zoom that out, that's kind of what, still not very used to doing this, but that's what it looks like from a very, very basic point of view. Now we need to put a label. We need to have a label so that we can actually figure out our connectivities. So we're going to start up here. We click on the label sign and it says, what do you want to call it? And I'm going to call it row 0. I want it to be orientated to, okay, so let's just edit that. Let's edit the label. Edit label, and I want it to be on the left of the dot. There we go. So the reason why I want it on the left is just so that it's a little bit neater. There's no real technical reason for it. On the left, row 1, connect up there, row 2, row 3, row 4, row 5. Whoop. Of course, you can always go back and change these as you need to. Row 6. Okay. Now down here, we're going to go column 0, column 1, column 2, column 3, column 4, column 5, and then our last one is column 6, but I will turn that over to the right just so it's a little bit neater to see. And we've assigned our columns and our rows. Now if you want to change these key maps, I will actually do this at a later stage. I'm just not going to do it now. I'm going to change the field reference, and I'm going to edit the reference so it says K1, just like that. And similarly, the is it? I don't know why it does that, but it tends to lock up after I change it sometimes. Wait, go back to the pointer. Yeah, not sure what it's doing. Why is it stuck? My pointer doesn't want to do certain things. I'm gonna hit save because it's not behaving. Alright, let's see if I can. Oh, it's thinking. I seem to have lost my cursor. What on earth is Kicad doing? Alright, let's just close schematic, and hopefully that has preserved it. It has. There we go. And my pointer is working again. But now I'm going to edit that reference as well. So it'll say D1, diode 1. This is really useful because if you're trying to diagnose something that's not working, having that silk screen on the actual PCB allows you to check individual components, because you go, well, that switch is key K1. I'm looking for diode 1 so I can test if diode 1's broken or not. And it would be exactly the same as if you're going to do resistors or any other components. Now, of course, for the purposes of saving time, I'm not going to go through and relabel every single item. And I don't know what's going on. Why am I losing my cursor? So, seems like there's something happening here where it's locking up, but I'm just going to kill that and go back in. Hopefully you're not going to experience the same problems as I am with that right now. Now we're going to place another component, and I want to put in my Pro Micro. So there's the Pro Micro. There we go. We're just going to drop that there. And this is when things start to get interesting, because we're going to be looking at mapping our rows and column assignment to it. You'll see there's the reset and raw, there's the VCC, the RX, TX, receive and transmit, and then we've got some ground pins, and then there's the number of workable pins that you can actually use. This is where you start making your actual assignments to rows and columns. Now there is a particular sort of trick, I suppose, to it, in that you want to be using suitable rows and columns. So I'm just going to save this, and I'm going to close that again. We're going to open the V2 project. So you'll see this is all the stuff that I was using for V2, and there's my schematic. And all I did when I started with this one was I just started up the top 1, 2, 3, 4, 5, 6, and then from the bottom 1, 2, 3, 4, 5, 6. You can assign them however you want, but the assignment will matter because the physical pins do not match the schematic pins. Let me repeat that again. The physical pin position do not match the schematics pin position. And this is evident by looking at Pro Micro pinouts. And I'm just going to bring up an example of a Pro Micro pinout quickly with a Google image, if I can find the one that is normally the one that's referenced. Here we go. Image in a new tab, and let's just bring that over there. Oh, what's going on? There we go. Right, so you'll see that your raw and ground and reset are already in completely different positions. And these pin assignments, though, usually are related to these different channels. So you kind of need to be a little bit aware of which one of these will equal to what. So A1, 0, 2, and 3 are over floating around somewhere down on this side. There we go. So there's A0, A1, A2, A3. And then the actual assignment of 2, 3, 4, 5, 6, 10, 16, 14, 15 is over here. 2, 3, 4, 5, 6, 7, 8, 9, 10, 16, 14, 15. So this wraparound means you need to run your traces to those physical positions. Now, it doesn't really matter at this point in time. You can just assign them however you want, because later, if you have difficulties routing your traces to these pinouts, you can just change these assignments. And then, of course, you just got to go back and mess around with your traces some more. But I will do exactly the same thing as I did last time, this time for the V3, in that I'll just put row 0 to 6, and then from row 0 to 6 up in the opposite direction as well. So let's get out of this schematic and head back over to the V3 project. Open up my schematic there, and let's just roll in a little bit closer. And now we're going to connect our labels. So now we want it on the right, and that's going to be row 0, row 1, row 2. I think the double enter works really well. That way you don't move your mouse and screw up the position and then have to find it again. What was I up to? 5, row 6, and then from down here below we're going to go column 0, column 1, column 2, column 3, column 4, column 5, column 6, and we're done. So now we've actually got 12 and 13 all as it is 9 and 10 still open if you wanted to actually go and make a slightly bigger or whatnot, add extra features or power or something else with PWMs if you want to change LED lighting levels and so on and so forth. And you know what? That is primarily what you need to do to create your schematic. The schematic is done. It's done. Now, of course, I'm going to save this. Do I still have the other one? No, it's not open. So I'm just going to check that my row goes all the way through. It doesn't need to be connected to the column, obviously. And of course, my columns go all the way through. Each one of these components should be fine. And lucky for me, I can always go back to another project and check it, because I do have a project that I know works, because I have it as a physical object next to me that worked. So let's just open that schematic, and yep, so my rows don't have to go all the way past here, and my columns just hit the switches, and then that's it. And so here you'll notice there's a void, which would be the right hand 1U of the insert, and then I've got this big fat void because my switches are in these rows rather than in the split rows, where I've now got those for the 2U split for the plus and enter. That's it. That is how you build a schematic. The schematic is relatively simple. You don't have to do terribly much. It doesn't require a huge amount of thought for a very basic matrix. If I was to do LEDs, I would have to have additional components here, because I would now start to put resistors and the LEDs in in parallel, and then they all have to go to a transistor and another resistor to the Pro Micro, so that there will be no overcurrent issues. And I felt, I didn't want to make it more complicated. I didn't want to make it harder to run traces, because running traces was really challenging for me when I first started, still is, and we'll discover how bad it is soon enough. Now, from this point on, you need to do some component associations, and you need to create a netlist. Off the top of my head, we're going to do the component associations first, and we're going to use okay, so it wants completely annotated schematics. Let's see how it'll do it automatically. Let's go annotate, and we will say okay, and it does it freely for me. Now it's just gone and jumped into the association window, but while it's doing that, let's go back. Is it going to let me? No, it's still thinking. It's still thinking. Elevator music. Okay, now I'm just going to go back to the schematic, and you'll see right, it's actually gone and dumped some numbers here in a really weird way. So it's left some question marks in here, and then it's got some weird row and column functions. Now I haven't actually saved it, so maybe I won't. I'm going to say exit without save. I'm going to exit that as well. Let's open my schematic again, and there it is, our unknowns. So maybe if I change this back edit reference to question mark. I don't know if that's going to work very well. Alright, you know what? I'm going to actually manually label all these numbers, but I'm not going to do it on the video. And then the next part of the video is where I'll go through creating the associations and then generate the net list, and then we'll go from there, because I really don't want to burn all that time doing this on video. So thanks very much for checking out this part. I hope it gives you a very, I suppose, simplistic look an understanding of building your schematic using key switches and diodes only. Of course, this does not contain LEDs, and then of course how you assign your rows and columns to the Pro Micro. And so right now we've been able to replicate this in a schematic format. Well, thanks very much for checking out this part, and I'll catch you on part 3.